Hi, my name is Ryan Stropik. I'm an Azure MVP, and currently I'm here at Tech at Europe in Madrid. Today I'll deliver a session about continuous integration, Windows Azure websites, and Team Foundation services here at the TechEd conference. And in this video, I want to go a little bit more into details about the sample. The time is limited during the session. It will be recorded, so you can take a look at it on channel 9, for instance. But in this video that I will publish in my private blog, which is www.software-architects.com. In this video, I want to spend a little bit more time going into the details of the sample, showing you some additional tips and tricks about continuous integration with Team Foundation services and Windows Azure websites. So let's get going. For this presentation, I have, of course, prepared an image in the cloud. The session is all about the cloud, and therefore I'm using infrastructure as a service for demoing this stuff. So it's only a question of minutes or seconds to set up, for instance, a Windows Server 2012, install an evaluation version of Visual Studio and other development tools that you want to have on this machine, and play around with it. So if you are new to Windows Azure or new to Team Foundation services, you don't have to install all the bits and pieces on your production development machine. You can use infrastructure as a service to try it out, and if you like it, you can put it into your production environment. So in my case, I've set up a Windows Server 2012 with Visual Studio, SQL Server Management Studio, an FTP program that we will use later, and some tools that are quite handy during development. So let's get going, and for those of you who don't know Windows Azure websites in details, those of you who haven't worked with it already, I want to start with a very short introduction of Windows Azure websites. Windows Azure Websites is, in my opinion, one of the coolest things in Windows Azure. It's a platform as a service offering for running IIS-based applications. So you can run your content management system, your web API, or your MVC application there. You are not even bound to .NET. You can use other languages, other technologies. I encourage you to visit windowsazure.com and take a look at all the options that Windows Azure websites offer you. In my presentation today, I will really focus on the .NET part. So you will see an MVC application running in Windows Azure website. We will deploy it manually. We'll set up continuous integration, continuous delivery. We will customize the build process. We will write the custom build action and use the build server in the cloud. That's a very important thing. So everything is running in the cloud. The source code repository, build server, website, and everything else. So let me introduce Windows Azure websites for those of you who haven't worked with it. As you can see, I'm here in the Windows Azure portal, and you see I already selected the website tab here, and it's quite easy to create a new website. You essentially have two options. Either you can say quick create, which is what you typically do if you implement your own .NET application, or you can also go through the gallery. The gallery contains some already installed and set up solutions like CMS systems, blog systems, and a lot of other stuff that, well, you can take a look at it. Just click on it, hit create, and in a matter of seconds you get a deployed version of, for instance, WordPress or Cantico or other IIS-based applications. But in this session, I want to concentrate on the development part. So let's close the gallery here and use the quick create icon. Let's call it, this is my demo app, Tech at Europe 13. Let's take a look. No one else has taken this name already. Let's put it in North Europe, as we are here in Madrid, in Europe, and create the website. Creating a website is a matter of seconds. If you have already worked with, for instance, cloud services, you know that deploying it, creating it, is a little bit time consuming. It takes a matter of minutes, some minutes, maybe 10, maybe 8, it depends. But as you can see, creating a website is really done in less than 10 seconds. We can take a look at it, and currently this website is, of course, completely empty. If we run it, we get a beautiful picture that says the website has been created but is empty essentially. How can we get something into this website? Well, you have to know that the Windows Azure websites are backed by a central storage system that serves the entire website. So even if we, for instance, click here to scale and scale up our website to, let's say, shared mode, you will find more details about free, shared, and reserved mode on windowsazure.com. You can also take a look at other tech sessions about dedicated entirely to Windows Azure website to learn more about it. In my session, I want to just show something else. I want to scale up to not only use a single IIS, I want to use a web farm in this case. And again, it's only a matter of seconds. And we have a web farm with a load balancer and everything set up. So when we now deploy content to our website, this content is in reality stored in Windows Azure Blob Store, and the Windows Azure Blob Store is shared by all IIS applications that you deploy. So, for instance, we could go to the dashboard and upload some content here using FTP. You see, every website has an FTP endpoint, so we just have to run an FTP program. I'm using FileZilla here, a very popular open source FTP application. You see the user here. And finally, you need a password. This password, you have to specify this password during the creation of your account. So in my case, I copy it from KeyPass, click connect, and that's it. I am connected to the storage that is backing my Windows Azure website cluster. And to make it very simple for the first session, we will create a static HTML page. Let's take this one, Hello Tech Ed, body, and HTML. And now let's save this into my documents library. Let's call it hello teched.html. And if we now want to deploy this website, it's really a matter of drag and drop. So we take hello tech.html, drag it here using FTP into our site directory. Sorry, I did something wrong now. Hopefully it works. Yeah, here it is, hello tech.html, and if I now go back to the site, let's launch it. It still says it's empty, of course, because I didn't configure anything about the default page and things like that. I have to specify hello tech here in the URI, and here we are. As you can see, Windows Azure websites are very easy to start with. Just set it up, few seconds, and use, for instance, FTP or a lot of other deployment options which we will cover later during this presentation. Whenever you need it, you can go back to the scaling, let's say during night, where you have less traffic on your website, and you can reduce it, instance count from 2 to 1. And now we scaled down our website and we pay less. That's the whole idea of the cloud. Only pay for what you really use. And as you can see, it's very simple to scale Windows Azure websites. Of course, this is possible from the command line tool too. So you can, for instance, schedule scaling up, scaling down as you need it. This was a very quick introduction into Windows Azure websites, just to make sure that everyone has a bit of understanding what Windows Azure website is all about. Essentially, it's an Internet Information Server where you can use different deployment mechanisms to deploy any kind of application that can run in IIS within seconds. So what is the second part of my demo? The second part of my demo is a Team Foundation server which runs in the cloud. And this thing is called Team Foundation Services. You can find Team Foundation Services at the URI tfs.visualstudio.com, and I've already registered for a demo account for TFS in the cloud. Now let's set up an entirely new Team Foundation server project. As you might know, those of you who work in larger enterprises, this is typical in your on-premise infrastructure, a bit of a challenge. Different departments are involved and things like that. Getting a Team Foundation server with build servers and test servers and things like that running takes at least a few hours, if not a few days. In the cloud, we just say new team project, give it a name, demo project, and wait a few moments. This Team Foundation server is the same TFS as you know it from your on-premise installation. Well, nearly the same. There are a few limitations, and if you take a look at the session that I do during TechEd, I have some slides where I name the limitations that the online TFS has in comparison to the on-premise TFS. So in our situation, the project has already been set up, and we are now here in the web interface of the Team Foundation services. Of course, it's not only a source control system and not only a build system, but you can also plan and manage your development work here. So it's quite easy to, for instance, set up a few backlog items. Let's say we have to create a database, and we have to develop the UI, and we have to make it look awesome. Okay, so when we've created our backlog items, we can use drag and drop, for instance, to schedule the creation of the database in Sprint 1. We can develop the UI also in Sprint 1. We can make it look awesome in Sprint 2. We can take a look at the board here, a graphical representation of our work. We can say, okay, create database has been approved, develop the UI has also been approved. Now we created the database, so we can put it to committed and things like that. All the things that you know and probably love from your on-premise TFS are there in the cloud too. Just to give you an impression what Team Foundation Services is. So what about source control? It's already there. You see you have the code node here, and on the home page we can even directly launch an instance of Visual Studio with it, which is connected to this demo project already. So you see, you have the source control explorer, and I can hit get latest version for our demo project here. I can take a look here. This is the folder that I can put my solutions into and add them to source control. Maybe you wonder where this build process templates folder came from in our newly created project. Well, bear with me, we will take a look at this folder later on when we start customizing build workflow and extending it with custom TFS workflow components. For the moment, it doesn't matter what this is. So let me quickly show you how you use Team Foundation Services as a source code repository, create a class library, put it in C, source demo project, class library 1, that's okay. Hit OK. Now we get our class library, move to Solution Explorer, and it's quite simple, just as you're used to with your on-premise TFS. Add the solution to source control, check it in, and that's it. As you can see, work with Team Foundation Services essentially in the same way that you work with your on-premise TFS. Let's go back to Source Control Explorer, and you can see here we have our class library project. Of course, we can also use the web interface to take a look at our code here. You will see the class library here. You can take a look at the change sets, the shelf sets, and all the things that Team Foundation Server is capable to do. Well, this was a short introduction into Team Foundation services, and the nice thing, and the rest of and this is what I want to dedicate the rest of this video to, is the integration of websites with Team Foundation services. Wouldn't it be great to have a project in the cloud where you can just check in your source code, and via check-in, the build process is automatically triggered. Unit tests are executed. If your unit tests succeed, the the resulting files could be automatically deployed to Windows Azure websites, and you can put it either in production or deploy it to a test system so that your testers can take a look at it completely automatically. So this is the goal of the rest of this video, to show you how to integrate websites with Team Foundation services, but believe me, we are not only going to scratch the surface, we are going deep into it, we are going to customize the build workflow, we extend the build workflow with custom components, and all the things that typically hit you in a real world project. So the rest of this video is not just hello world. But let's prepare the environment for our presentation. First, let me show you something. I have prepared a sample application. I called it Bee in My Garden. Why did I call it Bee in My Garden? You know, in my private life, I'm an apiarist. That means I'm holding I'm holding honeybees, and I love that. And I run my own blog. It's called Bienen im Garten. That's German for bees in my garden. And I have copied some content from my blog, and this is what we are going to build. I've prepared an MVC application that's able to display some content from my blog. It's using a SQL Server database in the background where all the blog content is stored. So let me open the solution for you and show you how it works. We open it in Visual Studio. It's not yet connected to any Team Foundation server. We are approaching Team Foundation server step by step. Currently, I'm completely running offline. I'm starting it by hitting F5, so debugging the solution. And please keep in mind, currently we are working completely offline, so we are not using any IIS in the cloud, we are not using any SQL Server in the cloud. The database, blog database, is coming from local SQL installations, coming from local DB. And as you can see, this is a very simple view for my blog, and I can take a look at all the blog items. I can say blog index. I can open one single blog, and if I specify a blog ID that has not yet been created, I will get a 404 error. Now let's take a look at the source code here. It's quite simple. I'm using code first. I'm using code first entity framework to set up the database. The database structure is extremely simple. It contains blog items. Every blog item has an ID and some textual information. And additionally, I have created a very handy functionality here. It's called generate demo data, and it fills the database, a newly created database, with some demo data with three blog items from my Apiarist blog. So what happened in the background, here you see Management Studio, and you see we have local DB on the local machine. Here we have our tables. Let's refresh this one, refresh it, and you see here, by starting the application locally using the debugger, the blog items table has automatically been created, as you maybe know from Entity Framework code first. This is done fully automatically. So this is a very important thing. It's completely running in an offline mode, and I've also created two tests that test my controller, which lives here in the web application. You see, I've created two tests here, and of course they are running fine on the local machine. So let's build a solution. Wait until Test Explorer discovers my unit tests. Here they are, run them. And again, the unit tests are entirely running locally. So they succeed locally, and again we are using, let me show you the connection string here, we are using local DB. So what are the takeaways from these first steps? The demo application is a small MVC application. It consists of a database, the MVC application, and some unit tests. And for development purposes, I'm entirely running on this local machine, no resources in the cloud, no website in the cloud, no IIS in the cloud, and no SQL Server in the cloud. So let's deploy this application. First step, we are not deploying this application using a build process, but we are going to deploy it manually, just to make sure everyone has seen it and to make it very clear what the difference is between a local deployment, manual deployment, and an automated deployment using continuous integration and delivery. So let's go to the websites here and create a new website for our Be in My Garden blog. Be in My Garden, Windows Azure website. I added the postfix Windows Azure website here to make it very clear for everyone who is watching this video what I do. Later on I will create a Team Foundation server project, and this one will also be called Be in My Garden, but I will add the postfix TFS just to make sure that you don't mix up where we are doing something with the websites, where we're doing something with the Team Foundation server. Create the website. And in this case, we will not use FTP, the very, very low-tech option to deploy our Windows Azure website. Instead, we are going to use the web deploy feature of Visual Studio to put our MVC application into production. So, what are we going to do? I'm navigating here to dashboard, and Visual Studio makes it super simple to deploy your application, your MVC application. You just have to download the publish profile for your Windows Azure website. You see that's a file, you save it locally. You go to Be in My Garden here. You hit publish and say import. And I've got something. So let's get back. Sorry, I created the website in Windows Azure website, but I wanted to point out a nice feature which is very handy, and this is this linked resources tab here. With linked resources, you can give Azure more information about how your databases or your data stores relate to your Windows Azure websites. So we can link our Windows Azure website with the SQL Server. We have it. I've already created. Oh, sorry. Did I select new database? Sorry, I wanted to say. Yeah. No. Here I want to say a link an existing resource because I've already created a database. Let me show this database to you. Here you see it's running in the cloud. Here we have it. It's called Be in My Garden SQL, and it's also entirely empty. So I want to tell Windows Azure that my Be in My Garden WAWS website is connected to this database, and of course we can specify a login name, and I've prepared a login name and a password for the sake of this presentation. Copy it, and that's it. Now Windows Azure knows that these two items belong together, and for instance, it can prevent you or warn you when you want to drop your database that your database is connected to a website, and maybe you change your mind and you don't drop your application. But something else is very important. Let me download the publish profile here again. Okay, this is the one. And go to Be in My Garden, and now we can really publish our website, import the publishing profile, and make sure to take the latest one. The second nice thing about linking your database to Windows Azure website is that Windows Azure and the Visual Studio is quite smart because it determines that you have in your web.config file a connection to a local database, to local DB. But in the cloud, you cannot access local DB. It's simply not there. On the servers in Windows Azure where your website will run, you don't have local DB. It makes no sense. You cannot access it. So we have to connect, we have to change the web.config file during deployment. And if your website is already connected with a SQL database, the web deploy mechanism here suggests that you can change your web.config during deployment. This is a very handy feature, and in our case we need exactly this functionality. So hit next and hit publish. And now comes the good part here, because if you have already worked with cloud services, you know that deploying a cloud service can take you a couple of minutes, but deploying a website is a question of seconds, as you can see. We're already done. Our website is up and running, it's in the cloud, we can access it using HTTP or HTTPS. It supports all the functions that you've seen locally, so we can access a single block, access all blocks, and if we access a non-existing block, we get a 404 error as we have seen in local installation. So deploying a website from Visual Studio is extremely simple, and for very small products or while you are trying out doing some prototyping, this might be absolutely enough. But our next step will be to integrate the website with our Team Foundation server to be able to check in source code by checking in triggering a new build, and the build should automatically publish our code, the drop files into our website. So let's start setting this up. In order to connect our website with Team Foundation server, we have to go back to the home page of our website and use setup deployment from source control. We can connect our deployment with the project which resides in Team Foundation Services. So let's create the target project in Team Foundation Services. Let's call it Be in My Garden TFS. Hit create project and wait a few moments until Team Foundation Services has created our new project. It's going quite fast, no problem. Yeah, you see, I love this status message. Your project is created and your team is going to absolutely love this. I really love this status message that the team has added here to the website. So now let's connect the website Be in My Garden WAWS with the TFS project Be in My Garden TFS. Set up deployment from source control. As you can see, there are a lot of different deployment options. You can go for, as we will do, Team Foundation Services, but you can use Git, you can use GitHub. You can even deploy your website if it doesn't need any kind of compilation, for instance, using your Dropbox account. If you have a static website and you just drop your images and HTML files to a Dropbox account, it will automatically be deployed to Windows Azure website very quickly. So in our case, we use Team Foundation Service. See, this is the name of the account that I'm using. Click Authorize Now. Now the system is checking whether your Life ID has the necessary rights, permissions to access the Team Foundation server you specified. And now you see I get a list of projects, and in my case, of course, I take the newly created repository Be in My Garden TFS. It will only take a few moments, and then our Windows Azure website will be linked to the Team Foundation Services project. And all we need to do to trigger a build now is check in source code. We don't have to do anything. If you can live with the existing predefined build workflow, that's all you have to do. Connect the website with the Team Foundation Services by specifying the name of the TFS and the name of the project, and you're ready to go. So let's try this one. I copy the entire application in the directory where my TFS project lives. Oops, let's take this one, close it, and let's go back to Team Explorer, source control. You see, now we have my Be in My Garden TFS. Let's get the latest version so that Visual Studio creates the directory for us. And now I can drop the sources into this directory. Let's open the solution from this directory. Just drag and drop in Visual Studio, and here we are. Here now we have the solution directly in Visual Studio, and all we have to do is we add the solution to source control. That's it. Well, nearly. It's not entirely ready. What we have to do is we have to add one or two additional things here. First one, for my oops, I don't want to create a new folder here. Let's drop it again. I have to add one specific directory, which is called templates. Please bear with me. I don't want to describe what this templates folder is. We will need it in a later phase of this demo. We will customize the build workflow, and for the customized build workflow, I will need this directory. So for the moment, just accept that I'm adding here one additional directory. It's not necessary for this specific demo, but we will use it later on. So, you see, I just added the solution, including the unit tests, to my Team Foundation Services server, and let's check it in. It's fine, check it in. It's done in a few seconds, and yep, that's it. Now, the difference to the sample that I've shown you before is that now we have a build tab here, and in the build tab we have a build definition. We got this build definition by linking the Windows Azure website with Team Foundation Services, and only by checking in our source code, we trigger a build. This build, you can double click it, is running. Currently it's only queued, but in a few moments it will run in the cloud. So Team Foundation Services will give us a virtual machine with Visual Studio Ultimate Edition installed on it. And another important thing, on this build server we also have LocalDB. So our unit tests can be executed on the build server using LocalDB because Visual Studio is already installed there. So running unit tests that are backed by a SQL server is absolutely no problem. It is covered by the standard build process that you get out of the box. But we have another problem here. In fact, I can really this one cancel it. Oh, it's already in progress, so let me refresh it here. Yes, we have to stop it. Why do I stop this build? Why does this build not make sense? Because the default build process, or the default build definition, will copy the resulting files as they are. And we have one big problem here. We have the problem that in our web application we have a web.config file, and this web.config file uses LocalDB. Don't mix it up. This is not the unit test part. This is the website. Our current web.config uses the LocalDB to back our blog implementation. And of course this will not run in the cloud, because on the web server that will serve our MVC application we don't have LocalDB. We have to switch it. When we deployed the application using Visual Studio Web Deploy, we had this nice feature that Visual Studio was capable of turning the connection string during deployment. But if we just check in the application as it is, the build server does not know about that. The build server does not know about the fact that it has to rewrite our web.config file. But the good news is we can tell it. So we can change the build definition here, and we can tell the build definition in the processing section that it should use the same deployment profile that we have used previously when deploying the website manually from Visual Studio. And maybe you know, or maybe you don't know, the deployment profiles, publishing profiles are stored in the properties folder under publish profiles, and here you see the webdeploy.pub.xml. This pub.xml contains the definition for the deployment, and we can tell the deployment process which will run during automated built on the build server that it should use this definition to deploy the application in the cloud. To see what happens, I will change here to detailed for logging, and again, now we have changed it. Now it really makes sense to trigger a real build. So queue new build. Okay, the build is queued. It will take approximately 3 to 4 minutes until we get it. While the build is running, I will show you what the magic of this publishing profile XML is really all about. If we take a look at the properties folder, publish profile, and open this web deploy, this web deploy publish profile, you see that we have settings here. We have publish database settings, which tells the publishing that it has to change the DB context, block context, to this connection string. And you also have the MS deploy parameter value, which will be used by the automated build. So this XML is now used during automated build in the cloud, and with this, everything should work out fine. With this, the block application, which is published during build, should run, hopefully. Let's take a look how our build is doing. Here we are. You can see, you can click view build details, and you can watch the build as it's going on in the cloud. Again, as I mentioned, it will take a few minutes and we will come back to here. Oh, it's already going well. You can see it done. If you are familiar with builds on local TFS, you will recognize some things like run on agent, initialize workspaces, and so on. This is a typical build process, and the build process that is really used is in a folder that I've shown you before, but for this folder I told you we'll come back to it later, and it was the build process templates folder. It was automatically created when we created our Team Foundation Services project in the cloud. Let's take a look at this folder. It contains one important XAML file here. It's called Azure Continuous Deployment, and we can open it just by double-clicking it. The Azure Continuous Deployment is in fact a Windows Workflow Foundation, a WF XAML file, and it controls the build. Those of you who are familiar with TFS on-premise might recognize this workflow. Isn't it nice? It is a really deep workflow with a lot of actions inside, and we will customize it later. Just keep in mind that the build workflow is just a XAML file, and it is checked in just as we checked in our source files. If you want to change the basic workflow of your build, or you want to take a look exactly what's happening during deployment in the cloud and things like that, take a look at this XAML file and we'll find all the details that you need for working. So in our case, for the first run, we want to stick with the default workflow, and let's take a look how things are going. Let's scroll down. And you see here we have msbuild.exe running, so the build was already done. The tests, you see, run tests. The tests are also executed, and let's go down here, and it's the build is in fact already done. The drop files are currently created. We will go back to that later, and here we are. It took us 2.4 minutes to run builds, tests, and deployments. You see, the tests were successfully executed. I can click on it, I see the details of the tests. We can go into all the details that we need for automated testing, and the website was deployed. Now take a look. I click on it, and crossing fingers, here we are. The deployment was successful, and you can even take a look at the history of all deployments at the Windows Azure Management Portal. We see the active deployment. It was deployed right now, 9:12 a.m. It's 9:30 a.m. on this virtual machine. So the deployment was perfectly fine, and just by connecting our website with Team Foundation Server and checking in source code, we successfully created continuous integration and continuous delivery. Well, you might think, that's nice, but in practice I always have to customize the build workflow. I want to extend it. I want to be able to build my own components into the build workflow and things like that. So how do I access the build server? short answer is you don't. You have no capability of accessing the build server directly. It's a pre-configured virtual machine. You can take a look at the MSDN library and look up all the software that is installed on the build servers. If you need anything during the build, you have to check it in. And this is what I want to show you for the rest of this session. With you, I want to change the build workflow, and I want to build a custom activity that is used during the build. The custom activity, as we cannot copy it with copy and paste to the build server, will also be necessary to reside in our Team Foundation server repository. So we have to check in the DLLs that represent the workflow, the additional activities that we need during build. And you know what the scenario is? The scenario that I want to work with you here is versioning. Maybe some of you do that already. As you probably know, every DLL has a version, and the version number is controlled with these assembly level attributes. Currently our assembly version and file version is 0000, and what I want to do is I want to make sure on the build server that every assembly gets the right version, and we want to derive the version number from the time of the build. Okay, you understand what I want to have? I want to have in the drop location not DLLs with version 0000. I want to have DLLs with a version that is derived from the current time on the build server. For this, we need to customize the workflow, and we need a custom build activity that is able to generate such a file on the fly based on the current date and time. So let's start with the custom activity. I've prepared this custom activity, and of course you can download it on my blog www.software-architects.com. It's here, generate version file activity. Let's open this one in Visual Studio. Oops. Now open it in Visual Studio. Where did I open it from? Sorry, I opened it from wrong location. I want to check it in a few seconds, so I want to open it from here, from my source directory. Now we have the right version here. You see, this file is very, very simple. It's a code activity, so it's derived from code activity, and it contains a single method. It's called execute, and this execute uses the timestamp to create a new version. And finally, it fills a template file, and this is where the directory that I mentioned before but did not describe before comes into play. Here, this templates folder contains a version.cs, and can see the placeholders here. It says 0 and it says 1, and in generate version file we essentially use, here it is, a string.format, where we use this version file template to add information from the version. Okay, so we have a template file, we checked in the template file, and this template file should replace the default settings with the default settings with the 4 zeros that you have seen previously. I think I don't have to open it again. Okay, so let's go for it. Build this custom activity. Build was successful, and let's add this custom activity to source control. Here we are. But now a very important step. We don't have to just add the source code of our build activity. We have to add the binary too, because the binary will be used by the build server when it executes the build process. So we have to add some additional things here. We go into the bin, and let's take the debug version, that's fine for me, and hit add here. And now we check in not only the source code of our generate version file activity, but we also add the binaries. Check it in. Nice. Now we have a custom activity, and we can go the next step. We can add our custom activity to our build workflow. Can you remember where the build workflow is? It was in the build process templates directory, and here we have this Azure Continuous Deployment 11 XAML. If I open just the file by double-clicking it, we could do that, but in this case, we have some problems because we cannot reference custom activities. So a good practice is to create a new project. It doesn't matter which project. I use a class library here, and I call it source. It's called dummy and dummy. It's not necessary. It's just a, let's say, a wrapper around our XAML file, and I add the existing XAML file. Please note that I use add existing item. Go to our source directories. Let's look up the build process and switch here to XAML, and here we are, Azure Continuous Deployment. And now notice I add it as a link, not adding it by copying the file. I add it as a link, and to make sure that we can use our custom build component, we reference the corresponding DLL. Now hit browse, source, here we have it, generate version file activity, bin, debug, and here we have our DLL. So now we can use our generate version file activity in the build process. We can open our XAML file and start working with it. Please understand that I will not go into all the details of this build process. I assume that you have some knowledge about TFS build customization. If you don't have, take a look at MSDN, take a look at Channel 9. There are a bunch of videos where you can learn the basics about TFS build servers, the usage of Workflow Foundation to control the build and things like that. I will just customize it, and for this, go into the run-on agent sequence here, and here right after initialize workspace would be a good idea to create the directory where our newly created version file will reside, and create the version file based on the template with our custom activity. And then we will tell Visual Studio that it should ignore the version file that I have added to the project, and instead it should use the generated version file with the correct version information in it. So first thing, let's create a directory here. Let's make the properties section here a little larger so you can follow what I do. Which directory? Well, that's simple. We say path.combine. We create the directory in the sources directory, and we want to use the subdirectory generated, for instance, just as an example. And for the next one, we need, oops, what is the problem here? Nope, no problem, already disappeared. Now we've created the directory, and now we have to take our template file and use our custom build activity to transfer it into a concrete template that we can use during build. And for this, we want to use our custom build activity, but Visual Studio does not know about it yet. So we have to tell Visual Studio that there is a custom build activity, and we can do so by selecting choose items, source, and be in my garden, and let's say we are bin, come on, bin, debug, selected. Okay, and now we have our custom component generate version file in Visual Studio. Let's drag it here and tell the system that inside of this newly created directory generated, it should create a version file that we want to use instead of the default version file. Here we are. What is the configuration? My config, it's not necessary. In practice, you will have some nice configuration names. You could also derive the configuration name from the current date and time, whatever you want to do. But now comes the important part. We have to tell our custom build component where the file should be created. And of course, we'll use path.combine sources directory, the generated subdirectory, and we want to call it version.cs. Please custom component generate a version.cs file in the subdirectory generated, which resides in our sources directory. Now we need a date, the date from which the version information is created from, and that one's easy, it's just datetime now. And now, last but not least, we have to tell our custom component where it finds the template of the version file. And this is, let's take a look, source control. You see, this is our templates directory, and here is the version file. So I click here and say path.combine sources directory. The name of the project is Be in My Garden TFS. Be in My Garden TFS. The name of the directory is called templates. And finally, the file should be called version.cs. So it takes this template, uses this input date to generate a new version file during build and put it in the generated subdirectory. You get the point? Quite simple, I think. Last step, and then we are done, and we can really queue our build and take a look if everything works out nicely. We have to tell MS Build that it should ignore the default version file and use our generated version file instead. For this, I have to start a second Visual Studio. Just to show you what I do here, I open my in my garden solution again, and I want to show you something that I've prepared in advance. So you see, here you have the version file that's per default used, and you see the 4 zeros as assembly versions and file versions. But I did a trick here, a small trick. Let's unload this project and let's edit it here in XML form. And as you can see, I added manually, not via Visual Studio UI, manually a property that is called version file. And this version file property uses the default version CS if no other version file is specified. And what we are going to do is we are going to specify this parameter during automated build. During manual build, this parameter will not be known, and therefore it will take the default version CS with the 4 zeros. But during automated build, it will take this parameter here and use the generated version file instead. If we scroll down, you can see I didn't include the version file hard-coded, but I include version file based on the parameter value. A very important step that you should not forget, otherwise the sample will not work. So let's reload the project. Here we are, just to demo it. So in our case, we have to look up the MS Build task, and we can do that by searching for it. Run MS Build for project. Use the current project, and it's looking. No, the first one is not interested. It's the cleaning part, and here we are. Run MS Build for project, and here we have the command line parameter. Let's edit it. As you can see, one parameter is already passed to this build, so we need to specify a second parameter, and this is called version file. And this version file is a string parameter, so we need double exclamation marks here and specify a parameter. And what is the parameter? It's the name of the directory plus file which should be used during automated build. So it's path.combine sources directory and generated. Can remember we create this this temporary directory during build in our workflow at the very early part in the build process, and there it should look for the file version.cs. And that's it. Now MS Build knows that it should set this parameter, and by specifying bracket missing here, it should use this dynamically generated version file instead of the default version file. So hit OK, save everything, and before we can go into Team Explorer here and go to builds and queue a new build here, we have to do one final extremely important step. We have to tell the build server where it finds custom DLLs that are used during build. Because now let's go back, all, collapse all, let's go to the process up here, run on agent. As you might remember, here we are referencing generate version file, which is a custom build activity, and the build server will simply not find it. But we have checked it in. Can you remember? Here we have it. We have manually checked in the binaries of the build of the custom build activity. But we have to tell the build server that it should look in this directory for custom build actions, and this is done here in the action menu, manage build controllers, and you hit properties on the top level, hosted build controller, and here you have the setting that's important. You just select it and you choose the directory where your custom build component lives. It's the generate version file activity, build, debug, and this is the directory where it should get custom build activities from. Now hit OK, close it, save everything, make sure that nothing is checked out anymore. Yeah, here it is, let's check it in, and finally trigger a build. If everything works out right, and I'm really getting nervous now, cue new build, then our triggered build here should use the customized build workflow, so we should be able to see in the build log that a new directory is created. We should see that MS-build is passed an additional parameter, version file, and we should see that our custom build component is executed to generate the version file out of the box. While this is running, I will go back to browser here. Oh, we are already here in Team Foundation Services. Go to code. No, sorry, build. Here we are. This is the previously finished build. It was successful, and now open it and open the drop location, just to make sure that you understand what the versions are all about. So here we are. Let's open it. Here we have the drop location. And if we take a look at the Be in My Garden data DLL and copy it to documents, we can take a look at the properties and see in the details that it has file version 0000. This is not very professional. If we want to deploy something, I want to immediately see what is the version of this DLL. I mean, you can come up with different algorithms, how you generate your versions. You can count up from 1 to I don't know what. You can use, as I do here, the date and time to see when was this DLL created during automated build. You get a clear indication that a DLL that was compiled manually by a developer always has the version 0000, but a DLL that was created on the build server always has a file version. This is the kind of thing that we want to achieve here. So you see here in the drop location, you can take a look at these DLLs and take a look at the result of your builds. And now our build should be hopefully out of queue and already running. And let's take a look at the log here. You see, run on agent, initialize workspace, and after initialize workspace, we should see, yeah, here we are, create directory and create version file. So the customization of deployment workflow definitely worked. It called our newly added actions, it created the generated directory, it has successfully executed our custom build activity that we specified for the hosted build controller. Now let's go back, let's see if MS build was already triggered. Yes, here it is. And we can take at the MS build log here, and somewhere here it is. We see that the version file, you see, the version file was specified here. Version file equals generated and so on version. And in this version file is the version that was derived from the build timestamp. So let's go down here, and yep, it already ran our test. It tries to associate change sets to the build. Of course, I triggered the build manually, therefore there are no change sets to be submitted to the build. And in a few more seconds, hopefully, we will see that MS Build adds all the resulting files to the drop location, and we will take a look at the drop location, and hopefully we will find version numbers there. Anything else that I can show you in the meantime? Well, yes, I can use the time and show you some additional things. A very important and handy feature. Imagine the following thing happened. You checked in some source code, and the source code wasn't as smart as you thought, and therefore you ruined either your test or even your production environment. I already have shown you that. Let's go to websites. Here we are in my garden. I've already shown you that you see a history of deployments. You see? And the important feature is that you can use a previous successfully deployment. You can use it, and you can choose redeploy. If you select redeploy based on an old deployment, you will essentially trigger a new build for this old version of your source code. Team Foundation Server will get the corresponding version from your source code history. It will run the build process again, and it will deploy the old version for you. That's an important point, because maybe you ruined something. Well, you shouldn't, but maybe you did, and therefore this is an important way to step back. So let's go back to our build has successfully completed, and you see tests were executed. Let's finally check if my Appearist blog still works. Yes, it does. And so we go back to our build server. You see, this is the latest build. Open it. Open the drop location. Open it. And now, crossing fingers, be in my garden data, copy it to, sorry, replace. Here we are, properties, and here we are. As you can see, the file version and the product version were replaced with data time. This is the year, 6 is the month, 26 is the day, 9:32 is the timestamp when the build created this DLL. So we finally succeeded. We have customized the build workflow. We have not only scratched the surface. You've seen that it's very simple to deploy to Windows Azure website manually from Visual Studio. You have seen how easy it is to connect the website with Team Foundation services. But as always, the mantra from Microsoft, the simple things should be simple, but the complex things should be possible. We digged deeper and we customized the workflow. We even added a custom build component in the TFS running in the cloud to really make it a build server that fits our concrete requirements. So, I hope you enjoyed this presentation and enjoyed this video. As I mentioned before, I will publish the source code and this video on my blog, www.software-architects.com, and of course, feel free to take a look at the presentation recording from Tech at Europe from here in Madrid. So, goodbye, see you next time.